Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to use YOLO object detection model and Google Gen AI, the Vision AI agent, and then we will use both and we will create custom object detection. Basically we will create more than just object detection. So before we move to our practical friends, if you learn something from our videos, please consider to subscribe our channel. Also you can click on join button. It will really help us to create more and more unique videos on this channel. So thank you so much friends. Let's get started. So friends, as I mentioned, today we will use YOLO object detection. We will create our own custom object detection model. Then we will combine Google Vision agent. So we will go the next step, or we will just say we will create the next level object detection. You will get the idea what basically we will achieve. So for that, first I will mention the link, the GitHub repository link inside my description box. Simply copy paste the link inside web browser as we always do. Go to the code, click on download zip, and it will download our zip format repository. As you can see, we successfully downloaded. Just open file manager, go to the downloads, and then this is what our repository. Right click and then click on extract all, click on extract. It will extract our repository. That's it. Now we have our repository. So friends, now we have our repository. Just open the folder. Again we have same folder. So first we need our data. So as I mentioned, we will create our own custom object detection model. So today we will detect Arduino Uno and ESP32 board using live USB web camera. So for that we will capture the images with the help of our live USB web camera feed. So for that I have created in the repository, I have created img.py code. This is the code which basically capture 5 images. So what basically we will do, we have here a surface, like I have here a table, and on that table I have set the Arduino Uno board and ESP32 board. So we can capture the images. So let's just say we want to move the board in different angle. So for that what we will do, we will capture the 5 images set, means the 5 images set with both Arduino Uno and ESP32 board. Then we will change their direction. Some of the time we will mention the ESP32 at the left side, or we will change the Arduino Uno to right side. We will change their position. So with the help of this we can create, let's just say I will create here a 50 images. So for that, this is the code img.py. It will capture the 5 images. So as I mentioned, we will create the set. So for that we need OpenCV-Python. So go to the tools, manage packages, OpenCV-Python, and it will search for OpenCV-Python. This is the Sony Python IDE. You can simply search for Sony Python IDE and download the IDE. So OpenCV-Python, which is the first package, just click on install button, then it will install OpenCV-Python. And then here I have mentioned my USB web camera. Okay, so it will start the camera, and then we can simply capture the images. As you can see, the 0 is the index number for the camera. So let me show you. It will create images folder inside the repository. So if I start the code, you will see there will be, as you can see, there is a Arduino Uno board and there is a ESP32 board. So inside repository, inside our repository, now there is a images folder and we have 5 images. Okay, as you can see, 5 images. So in these images, now let's just say this is let's just say this is the left side or this is the right side. So now what I will do, I will change the board side. So let's just say I will move the Arduino Uno over here and then ESP32 over here. So this is how you can change their position and you can collect the data, the images data. So now I will change their position. So friends, I have changed the position. Now if I start the code, now it will capture next 5 images. As you can see, now we have a next 5 images inside downloads and our repository. Again we have images. Now as you can see, we have new images. So here it is. As you can see, the position is changed. So this is how you can collect the data. You can simply collect the data. Okay, now again we will change the position. So if I start the code, as you can see, now we have 14 images. Now we will, let's just say, we will change their direction, because we need a different angle data. So we have 19 images. Now we will collect only one board image. So I have set only ESP32 board. 24. Now only Arduino Uno board. So only Arduino Uno board, 29 images. Now what we will do, we will again make like this way. So let's just run the code. Again I have changed their position. (39), 44, done. So we collected 49 images. Now if you open our repository, inside that we have images folder, and then we have 45 images. Okay, as you can see, a different angle images. So we have now our data. That's it. So we have now our data, we have our images. Now what we will do, we will start our training. We will open RoboFlow. So just sign up with your Gmail account, create new account, and then you will see this kind of page where you can create your new project. So click on new project, RoboFlow. Here you have to mention the project name. I will mention YOLO12. You can mention any. Annotation group, this is just a group name. Mention just a object. Then project type, we will select object detection. So select the object detection, click on create public project. It will create our project. Now here we will upload our folder. So click on select folder, and our repository downloads. This is what our repository, smart object detection, and this is the images folder. Click on upload, and then pop-up message, just select upload. Now it will upload all the images. So this is what our images, 50 images. Now go for save and continue. It will save our images on RoboFlow cloud. So we uploaded our images. Now just click on start labeling. Here you have to mention your Gmail ID. Just mention it, and then click on assign to myself, and then click on start annotating. Now you will see this kind of tool. So here we will go with the bounding box tool. So select the bounding box tool and draw the rectangle on the Arduino Uno board like this way. Simple. And mention the class name, which is the Arduino -Uno. Arduino -Uno, and click on create class. It will create the class Arduino -Uno. So this is what our first image. Go for next image. Now here we have Arduino Uno and ESP32 board. So just draw the rectangle on ESP32 and mention the class name ESP32. Click on create class. It will create the new class. Then draw here rectangle, and then because we already have Arduino Uno class selected. And then here you can simply select the box prompting. So from next image, if this box prompting tool detect the object, then there is no need to draw the rectangle, it will automatically draw. So let's just cross check, go for a next image. Here we have Arduino Uno and ESP32. As you can see, it's automatically selected. This is what the Arduino Uno and this is what the ESP32. Just click on approve to production, go for next image. As you can see here, it says this is the ESP32 and this is the ESP32, but this one is not ESP32. So simply what we will do, we will just select the bounding box tool, and this is the rectangle, this is the bounding box which we will delete. So right click, delete, and draw them manually, simple, manually, and then select the class. Okay, now again the box prompting tool will be checked. What is basically the object basically. So click on approve, go for next. So now let's just check. Here it is. As you can see, it's automatically selected. Go for next image. If the tool not automatically select, no problem, just delete it and mention the perfect class. Okay, so here as you can see, it's detected this one is the Arduino Uno and this one is the ESP32. There is no need to change anything. Go for approve, go for next image. Now here we have only ESP32. It's automatically selected because we use here the box prompting tool. So approve it, go for next image. Again we have only ESP32. Approve one prediction, go for next image. Let's just watch over here. As you can see, it's detected perfectly. So this is how I will complete this annotation process. So friends, we have completed our annotation process. This is the last image. As you can see, we have completed 50 out of 50 images. Now let's just go over here where you will see your project name YOLO12. As you can see, when you move your mouse cursor over there, it will highlight it. Just click on it, and then here you will see unannotated 0 and annotated 50. It means we annotated all the images. Now click on add 50 images to dataset. The method we will use split images between train, valid, and test. Select it, click on add images. Now it will add our images. Let's just close this their ad, and then versions, select it, click on continue, and then create, click on create. Now as you can see friends, if you click here, we will get our data set, but first we need to open our Google Colab. So let me open Google Colab. So I have opened Google Colab. Now click on upload, click on browse, and inside downloads I have mentioned the repository, and inside that we have our Colab file. Just select it and upload it. So we uploaded our Colab file. Go to the runtime, change runtime type, select Python 324 GPU, click on save, and then click on connect. We connected. Now we will run our cell one by one. So first cell. Now the next cell will install Ultralytics. So we successfully install Ultralytics package. Now let's just go for next cell where we import our packages, and the next cell where we cross check if Ultralytics is perfectly installed or not. For that we will use YOLOv12 n.pt model. So here just change the S with N, nano model. So YOLOv12 n.pt model, and the image which we will use for cross checking, which is the doc.jpeg from RoboFlow. Run the code, run the cell. Now it will use YOLOv12 n.pt model because we install Ultralytics, and it will run the object detection on this image, doc.jpeg image. From this image we have one person, one car, two dogs. It means we successfully detect object. Now here in custom training we will remove this from to YOLOv12. So just select the from to YOLOv12 using the mouse, click on delete button, it will delete the code. Now open the RoboFlow page where we left, go to the download dataset. Here we want to go for txt, Inside txt we will select the latest format, which is the YOLOv12. Select the show download code, click on continue. It will show the code, and then the code, as you can see, the same code which we delete from. So just copy it from to YOLO12, copy as it is, and just paste it here. After pip install, just Ctrl+V, visit or victory, it will paste the code. This is the code from to YOLO12. We have to paste it over here and then just run the cell. It will create the dataset folder, and inside that folder it will paste our project folder which we created on the RoboFlow, along with the test train valid folder. Also we have data.yml file. So we have done, as you can see. Now just click on this small folder icon. Here it is, as you can see, the dataset folder, project folder, and inside that we have test train valid and data.yml file. Just double click on data.yml, it will open the file like this way. Here this is the class, this is the name, and train valid test. So here we want to mention the real folder path. So train is here. Then when you move the cursor over the train folder, you will see the highlighted 3 dot. Select it, copy the path, and just remove the old path from the data.yml file. Ctrl+V, it will paste the path. So valid 3 dot, copy path, remove the old path, Ctrl+V. Test, go to the test, copy path, remove the old path, Ctrl+V, paste it. And now we have done. Now we want to save our data.yml file. So you will see right now I am inside this data.yml file because there is a cursor blink. Press Ctrl+S and save the file, close it. Done. Now the last code where we want to mention our data.yml file path. So data is equal to, this is the old data.yml file path, remove it and mention the new one, data.yml, highlight 3 dot, copy path, go here, data is equal to Ctrl+V. Done. Now as I mentioned, because we will use here a nano model, so YOLO12 n.pt, because I don't have a GPU. If you have a powerful GPU, you can simply mention YOLO12s. It will create that particular version, that powerful model. But I will go with here YOLO12 n.pt model. Run the code. Now our training started. So friends, our training is started. It will take some time. Let's just wait. So friends, we completed our training session and our model is saved inside runs, detect and train. So go to the small folder icon. So runs, then detect, then train, and inside that we have weights folder and then base.pt. This is what our model. Click on 3 dot and download the model. So we downloaded our model. Let's just close the Google Colab and RoboFlow also. Minimize all these things. Minimize the Tony Python ID. Open file manager, downloads. This is what our model. Right click, cut it, move the model inside our repository. Paste it. Now first we will use the simple object detection. Then we will add our Gen AI. No worry, I have mentioned the full code also. So for normal object detection we have nm.py. So open the nm.py with the help of Sony Python ID. I will close img.py because we have done with img.py. So we need here packages, opencv-python, which we already installed. So we need ultralytics. Hit enter. First package, click on install button, it will install ultralytics. Then we need cvzone package, cvzone, hit enter. First package, click on install button, done, it will install cvzone. So this is the packages which we need for normal object detection. Ultralytics, opencv-python, which we already installed for img.py, and then cvzone package. So ultralytics and cvzone. Now we mention our model. We will use the USB web camera, and we have here basic object detection method x1, y1, x2, y2 from the ultralytics. We will put the name of our classes on the rectangle top left corner. So let's just run the code. So friends, as you can see, we are detecting our object. So this is what our Arduino Uno board, As you can see, it's live Arduino Uno, and this is what ESP32. So if we go with the single board, we have Arduino Uno, then I will put ESP32, Arduino Uno. Okay, you can change their position. So this is the normal object detection. Now friends, as I mentioned, we will use here Google Gen AI, our Vision AI agent. So what I want here to achieve, I want to know that the position. So let's just say if I set this Arduino Uno over here and ESP32 over here. So let's just say the Arduino Uno position is the left side and ESP32 is the right side. Now let's just say if I remove the ESP32 and if I put here Arduino Uno at the center, so I want to know that what is the current position of my Arduino Uno board, whether it is left, right or center. So for that we will use here Google Vision agent, the Gen AI, Google Gemini Vision agent. So this is what our normal object detection. It is really easy. We have to create our own custom object detection model. I have mentioned the img.py. You can create your images, train the images, use Google Colab, you will get your model. But we want some more extraordinary object detection. So for that, here what I want to achieve, as I mentioned, I want to know what is their current position. Means if the left one is what, let's just say if the left one is Arduino Uno, so if the right one is ESP32, or let's just say there is only Arduino Uno, so what is their position? So right now we can say the Arduino Uno is basically now at the center. Simple. So for that we will use Google Gen AI, our Vision agent. So let me open file inside repository. I have mentioned the test.py. So we have done with normal object detection. So let's just close nm.py. So first for test.py, we need Google Gen AI key, the API key. So let me open the Google Gemini API key page. So I have opened Google Gemini API, Gemini Developer API, just click on it. Then here you will see this kind of page. Go to the solutions, Gemini API, get Gemini API key, and here I have already created one. I will delete that one and then click on create API key. Select any of your project, click on create API key. It will create our API key. Now let's just copy it, close it, and then open Sony Python IDE, and here just mention your API key. Remember one thing friends, you have to create your own API key. And Gemini 2.0 Flash model, which is the latest model. We have mentioned here our base.pt because we want to combine our YOLO object detection along with the Gemini API, means along with the Gemini Vision agent. So base.pt, which is our YOLO object detection. Okay, so then we have here CV2.video capture. It will start our USB web camera. And for Gemini Vision agent, we need to convert our image into base64. For that, this is the function, helper convert frame to base64. So this function will convert our frame into base64, because what we will do, we will send, when we start our camera with the help of OpenCV, we will start our camera frame. Every 5 seconds we will send new frame to Gen AI to recognize what is the current position of our both board, whether it is left, right or center. Simple. And then this is the function Gemini worker. This is the function, and this is what our agent, as you can see from this image, identify the horizontal position, which is the left or right of the following detected object. Join the latest object name. So latest object names is basically, we created here latest object name as a set. So because we have our object detection, as you can see the object detection, so with the help of object detection we will set the names, we will send the name, the current detected object names into this latest object name set, latest object name set. Let me show you here as you can see latest object name set, simple. And then the Gen AI result which we will create as a dictionary. So Gen AI result is basically, what is the Gen AI result? The Gen AI will recognize the current position of our object, For that Gen AI will use the detected object text, the detected object names from our YOLO object detection, Here it is, as you can see the current visible names is basically the name. And every 5 seconds, after every 5 seconds, because we will send here the frame every 5 seconds, so every 5 seconds we will send the latest object, means it will check the current object, and when we have after 5 seconds, because we have new frame, so again we want to send the latest object names. That's it, simple. And because all this process will hang our current live frame, for that we will use here threading method. So all the Gen AI method will go as a separate threading. Start Gemini thread. As you can see, we have mentioned the Gemini worker, which is the function which we will run separately. So it will not interrupt your live frame and it will go really smooth, simple. So now this is what our full code. Now let's just watch result. I have mentioned the key and I have set the board. Now let's just run the code. So as you can see, first it will detect the normal object, then every 5 seconds it will send the frame and then it will show the result. As you can see, ESP32 is the left side, this is the left side, and Arduino Uno is the right side. Now what I will do, I will simply change their position like this way. So I have changed their position now. So as you can see, now Arduino Uno is the left side and ESP32 is the right side. Now let's just say I will remove the ESP32 board and it will say here missing ESP32, and then it will check their position and it will say that the Arduino Uno is the right. Now let's just say if I make here like this way as a center, try to make at center. So I hope it will the center of the Arduino Uno. As you can see, it says the Arduino Uno, the position of the board is now center. So now it is center. Now let's just say if I mention over here our ESP32 board. Now let's just what will be the result. As you can see, the result is now changed because we add our ESP32, which is the new object. So ESP32 is now the left side, and the Arduino Uno which will the right side. Now if I remove the Arduino Uno, it will says the missing Arduino Uno. There is no Arduino Uno, but the ESP32 is still at the left side. So it will say the ESP32 at the left side. Now if I try to make here at the center, so I hope it is the center. Let's just watch. As you can see, ESP32 at the center. Now let's just add our Arduino Uno board again. First it will be detect the Arduino Uno board, then every 5 seconds it will send the new frame. Now we will get the result. As you can see, the Arduino Uno, it's now the left, and we have here ESP32, which is the right side. So friends, this is how you can use the YOLO object detection. You can also add the Gen AI vision agent, and you can create the next level object detection where you will get their position. you will use this method in robotic world. Let's just say you have the robotic hand, and when you have the robotic hand, you need to know what is the object which you want to put, or let's just say which you want to pull with the help of the robotic hand. So for that you need to know the object position. So with the help of this you will get the object position. Now let's just say if I here on the Arduino Uno, so this is now the left, this is right now the left. So let's just watch, it is continually said that the Arduino Uno is the left. Now let's just go for right. So this is basically the right. Now again after 5 seconds we will get the result, because this is the free version. If you have the paid version, then there is no need to wait. As you can see, the result change, it says the right. If you have the paid version of Gen AI, then there is no need to wait also. There is no need to wait for 5 seconds. So now let's just add our ESP32. Let me make like this way. ESP32. Now it will change both object position. Actually this is the right, so it will not change this Arduino Uno position. And let's just watch for ESP32. As you can see, ESP32 left and Arduino Uno is the right. So this is how, friends, you can use YOLO object detection. Also you can merge Google Gemini Vision AI agent, and you can create next level object detection. I have mentioned the full code. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.